Welcome back, ladies and gentlemen, to another Murph Codes HTML, CSS, and JavaScript session. Last time I showed you a little tiny taste of JavaScript, and we had an epic story time. So we didn't really talk about much else. And I do feel a little bad about that, but not really, because, if you're watching me, you're basically my captive audience, and I'll tell you whatever I want. You listen. Uh, if you enjoy story time and whatnot, great. If you don't, go get your code lessons from somebody who does less story time, I guess. I don't know. Anyway, today I have a massive amount of wisdom to impart on all of you. Absolutely massive. Okay. So, if you've been following this tutorial, you're probably looking at this going, there's a whole bunch of extra garbage in your files over here. And yes, there is a lot more garbage over here. Also, what is this doohickey? What that's new. That wasn't there last time. But as you can see, our page is still very much same as it was. I mean, I did change it so that the background is just the same color no matter how big or small we make it, because we don't really need to emphasize our breakpoints anymore with a different background. And normally you wouldn't do that anyway in regular development. I was just doing that to emphasize layout breakpoints. So when we were doing our CSS, things made sense. You could see with a real visual pop where exactly our breakpoints were. Now, it's all the same color. It's more consistent to what you would actually expect when developing a website. And we still have the navigation bar disappear and our little burger menu popping up. That all still works. I don't know if I really talked about this part, but notice our header just kind of stays in place now. Yeah, I fixed that part. Don't remember if I told you guys about that, but what I did here was, okay, header position sticky, but then I also had to position it. Okay, you can't make something sticky and forget to give it a position. It does not work. It's not just going to be like, okay, so it's going to be in the normal flow of things, because then when you scroll, the normal flow of things is to scroll off of the screen. If you want to make it sticky, you have to give it a position relative to the window. So 0 pixels to stick it right at the top. Leaves it there. It ain't going anywhere. Now you might be noticing there's another value here, another property here we've defined. We didn't talk about this one yet, but I want to demonstrate what this is. the Z index value. Okay, why do I have that set on the header? And why have I gone with a value of 5? Well, the simple question is, or the simple answer is, Z index determines how these elements stack if they should happen to be occupying the same space. All right? And it's kind of a depth thing, you know? Like, well, let me just show you. Okay, so our header is this box here. It's very plain. But notice when I scroll, the yellow box here disappears behind it. The purple boxes lay on top of it. All right? And the reason for that is while the header, this dark blue box, is set to a value of 5, my center isn't given a value at all. Cells are given a value of 7. And the board, which is the whole thing, is 3. So that center is inheriting the parent elements styles. So if you don't overwrite certain styles, it'll just inherit those styles from the container element, in which case Z index of 3. 3 is less than 5. So 3 is going to be behind or underneath the 5. But our cells, those purple boxes around it, right there, they're given 7, which is higher. Now, I like to space out the index values in case I should come up with an intermediary element that I want to stick between there. So I usually go up or down in value by a fair number. Here, I went with less than what I would normally do. You do you, though. Okay, if you want to just go 1, 2, 3, 4, 5, one at a time because you already know what you're going to do and you're fine with adjusting the values later if you need to make changes, go ahead. But for my money, I like to go with like a 10 scale. Unless I'm going to have like a lot of elements, and then I'll probably go to, a higher scale. This number, you can go with just about any value range you want. It just has to be an integer. The higher the integer, the higher in the stack it is, or the closer to the viewer it is. The lower the number, the lower in the stack it is, the further from the viewer it is. So things with a higher number will be placed in front of things with a lower number. And that'll come in handy when doing your layouts because you'll have things like this, where you want to be able to scroll right on through and you don't want your text rolling over your header. So you give it a z-index value that pulls it in front. Like everything, I believe, defaults to 1 or 0. Now, if I want to make it so my... There we go. Now what this should do... There we go. Now, what is this thing exactly? This is just a bunch of divs. All right? I have one container element, And then I have 3 row elements. That middle row element is divided up into 3 sections. There's a column, and a center. And the top row just has 5 cells, all floated to the left, all given a height and width. Bottom row element, same thing, all floated to the left, height and width the same. The columns each have 3 cell divs. That's divs given this cell class. The column, though, is set to the height of, or the width of exactly 1 of these cells. And then the center is given the height and width of 3 of them. Now, I did have to fudge the numbers a little bit because we get to some padding issues. Padding and margin issues. You have to be able to, with the box model, unless you're using like a Lex grid system or one of the CSS libraries that collapses down your margins and your borders to be included in the height and width of your divs. So this width and height property would include margins and borders. You have to account for that extra space. So if you give something a margin, its total width and height, you have to include its normal width and height as declared, plus the margin. So for our 50 pixel box, we have a width, but we also have a margin of 1. Padding is already included. That's the space on the inside of the box, between the edge of your box where the color change occurs. This line here, there'd be a 1 pixel buffer around the inside there, where content is just allowed to freely be displayed. So yeah, if we threw some text in this box here, our center box, let me see here. Do I have padding on that one? I do. I have 3 pixels of padding. There would be 3 pixels between the edge of this this yellow and whatever text we threw in here. Of course, that's all subject to also like text alignment and things like that, but text would not be allowed to extend beyond that 3 pixel border on the inside of our box. Margin is the space outside of the box. Notice how there's this little tiny gap here. I know that that is a 2 pixel wide gap, and the reason that I know that is because our cells each have a margin of 1 pixel all the way around. We're using shorthand here, so 1 value that indicates applied to all sides. If we did 2 values, like if I did that, this would be top and bottom, this would be left and right. If I did 4 values, we're looking at top, right, bottom, left. Trouble. TRBL. That's the order that goes in. So it's either top and bottom, left and right, or top, right, bottom, left when you're declaring margins and padding using the shorthand. You can, however, do something like this, where you just declare it for the one individual side. All right? So if you wanted just to declare a ruling for margin on the left, margin on the right, margin on the top or the bottom, you would put margin dash whichever side, and then how much of a margin you want to give it. All right, let me get rid of that because I don't want to mess up my code here. Okay, doesn't look like I've done that. Okay, good. Now, yeah, I know I said we were going to do JavaScript, and here I'm talking about CSS again, but I just wanted to go a little more into detail on the CSS side of things. Because if you get good at it, you can do stuff like this, or you can do entire art in HTML, just declaring the size and shapes of boxes, arranging them like pixels, and you can draw pretty much whatever you want as long as you have decent basic control of, placement figured out. All right? Now, something that really helps with that, notice that up here we have in the body, the parent container. We've declared some of that stuff. Normally I would put it in the asterisk where I would just clear out margins and padding to be 0. And then I would set those things as I go. Because when you set it to 0, everything just naturally inherits the property of its containing containing element. So, like, everything inside of the body, which is everything, would just naturally have, to begin with, a top and bottom margin of 0, top and bottom padding of 0, and then it becomes whatever we declare it as we're going along. All right, so how did I do this? Well, I set a board, which is the whole thing, because it kind of looked like a game board. But it's actually a soundboard. More on that later. It's a div with a block display type, width 260, height 260, so it's square. I know 50, 50, 50, 50, 50. That's that's only 250. Well, let's see what happens when I move this to 250. Show you what that looks like. Oh my god, the whole thing just kind of imploded. What the heck? Well, I tell you, this is what's known as the really stupid, annoying problem with trying to size things. That's what I call it. So, I always try to make the containing element just a little bit bigger. It's a little bit bigger. And then using proper use of float technique. Float is just telling things how to line up. We're doing float left, so just floats the next one as far to the left as it'll go, given that there's other elements inside of the containing element. This one is floated to the left, which allows things to line up on its right. All of the overflow of this row is just, oh, well, this element's floated to the left, so there's room here for the next one, which is also floated to the left. So there's room here for this one, which is floated to the left, so to its right is room for the next one. And then, oh, hey, there's still room for another one, and we still have one left. The rows, though, I have those being 100%, so they take up the full width of their containing element, this board. I didn't set a height though. I didn't set a height though, and the reason I didn't set a height though is because I have 3 rows here. I know it doesn't exactly look like 3, but this top set of 5, this bottom set of 5 is 1 row, and then these 3, this center block, and these 3 all consist of another row. But within that row, we have a column container, the center container, and another column container. The column containers are exactly 50 pixels wide, which means there's not enough when we float our cell to the left for there to be another element. So where does it go? Exactly 1 down. And there's room because I have the column extending the full height of whatever's in that space. And what else is in that space? My center block that has 148 pixels with a margin of 1 on the top and bottom. I had to give the center 2 pixels to the left and right because for some reason when I go with 1, which it seems to me 1 should be the correct value here, but as you notice, this doesn't quite line up. So somewhere my math is off a little bit. So we have to go with 2. I can't go with 2 here, though, because when I go with 2 here, even though this is square, all of it's square, I get a bit of an extra space here. I don't know why it does that. Somewhere I'm thinking my math is probably just being weird. So, it could very well be that there's some kind of property that's being covertly set and I'm not overwriting it properly. I don't know. That happens sometimes because your browser will have a CSS style page as well. Okay, and anything you don't declare, it will have a default for that. Now, a lot of time it's predictable. A lot of the time, uh, you can actually look up what your default browser's CSS is going to be. Not always, though, because sometimes you may have gone through and changed it inadvertently, not realizing that you've changed what the CSS your browser is using is going to be. And you could do that in the settings when you're changing like font styles and stuff. Like that's all handled by your browser's CSS. I know, who knew? Who knew browsers had CSS? But the order, and remember, rules declared after overwrite rules declared previous. Your browser's internal CSS is the first style sheet. Like even before we get to our own style sheet here, there will be your browser's internal style sheet. And then there's your style sheet. And then there's the inline or the internal style tags, and then the inline overriding that. So keep that in mind when you're setting your stuff up. So we have our board, we have our row, of which there are 3 of them, our cell, of which there are 16 of them, columns, there are 2 of those, and center, there is 1 of those. I could have gone with an ID, but I decided I was going to go with a class here. And the reason for that is if I decided to add another one of these, I can do that. Oh, I'm still on the intro, aren't I? Nope, that's not it. That's what I want, right there. Alright. I don't know why I switched over now, even though I just did, but we're going to quiet that background music. Because I want you to be able to hear this. Hoping you can hear this. Not sure if that worked. There we go. What the heck just happened? Alright, so, like I said, this is a soundboard that I've made. Ooh, we got some good sound effects this time. Oh, that's a duplicate. So, clearly, we're playing with sound. And, why are we playing with sound? Well, we're playing with sound because I wanted to be able to show you all how we can do some fun stuff in JavaScript today. All right, and now that we're done talking about our CSS, now we're going to start hitting that JavaScript hard. Although, there is one thing I do want to talk about before we get into the heavy JavaScript here. And it is one more style thing. I know we're looking at half an hour in, and I said this was going to be about JavaScript, and we're barely even hinting at what we're going to be doing in JavaScript. You may notice up here in the corner, we have an icon now. It's not just a random page, little globy thing, but we actually have an icon. Really hard to see on this video, I know, because the video is small and mostly our icon is white, but let me show you what that is a little better here. All right, this is our icon. How did I make the icon? Well, this was something that was bothering the heck out of me. Because I'd go over here, I'd go into the more tools, I'd open up the developer tools so that I could see my console, because, spoiler alert, there's gonna be something over here that we're gonna want to look at in a bit. But I kept getting an error about the fave icon wasn't set. And the fave icon is that little icon that just the picture that shows up next to your page title. on the tab, but also when you bookmark it. Let's look at our bookmarks here. Notice that little icon is there as well. If you were to pull this up on your phone and do the whole add to home screen option, it'll give a little icon for the page. And depending upon your device, it'll have a similar little icon. And you can control what that icon is. The easiest way to do that is to create an Ico file. What's an Ico file? Well, it's just an image this smiling cat here, we made this in Paint with just some line art. You know, you can get as fancy or as complicated as you want. It is 512 by 512, I believe. No, that's not what I want. And now the picture's gone. Properties. Details. Yeah, 512 by 512. It's just a ping file. Nothing terribly fancy. But whatever you can draw within that space, go to favicon.io/favicon-converter, and you can use their favicon converter to turn any JPEG or PNG, which is fully within the capability of any imaging software, to turn into an icon. So you just drag and drop into this box, hit download, it'll give you a zip file. You just extract that zip file, and it'll have the files named already. If you don't want it in the root directory, just make sure that in the code, because they give you the proper codes to attach your HTML, in your HTML, your favicons appropriately. Because what you'll notice here is we have Apple Touch icon, and then we have sizes of 32 by 32 or 16 by 16. We also have this manifest file. We'll talk about that in a minute. But as you can see, it gives you favIco, which is just the standard default icon. This one's using 48 by 48. We have 16 by 16 or 32 by 32. So, like, depending upon your browser, it'll choose one of those three, but this is the default one. It's just an Ico file, an icon file. You could actually take applications on your Windows desktop and change the icon using that same icon file. So why do we have all these different sizes and whatnot? Well, different use cases require different sizes. And this site web manifest can kind of tell us a little bit about that. Android if we're using Chrome or the Android browser, and we do the set to home or add to home screen um, option to put the little icon on there, that'll just bookmark or link directly to that site. Depending upon what your system is set up to do, it'll choose one of those icons. That's what the site web manifest does. It tells it's a file read by the browser for mobile devices. If you have it served up, my server isn't set up properly to issue those documents, so I have it commented out, so it's not going to do that. But on Apple, they just have it as one of the link elements, and then we're linking those other two depending upon whatever the browser is choosing to display. Some browsers will go with different sizes. I don't know what the defaults are for each one. I don't know if you can change the default size for each one. It's probably a thing you could do somewhere. And I'm pretty sure all of that information exists somewhere on the internet. If you want to look it up, it's out there to find. But this website gives you everything you need to put that little icon on your web page. You just copy this HTML after you download that file. You paste that HTML. I usually put it between the meta and the style sheet. So this is the code that I got off of there. I commented out the web manifest line because it was still giving me an error because my server is not set up to handle that file type. Because apparently I didn't bother with that in the settings. Not that that error does anything as far as like making the page not work. I mean, you can get all kinds of errors over here, and your web page will display exactly the same as it always did. But as you can see, I think, just check. Yeah, as you can see, I'm getting a bunch of errors over here now. And my page still displays absolutely the same as it ever did. No different. I still even have the little icon up in the corner. Like, you can get away with certain errors. It's not going to be a big deal. I comment that out, though. And that's what this is here. Open bracket, exclamation point, dash, dash. And then at the end, dash, dash, close bracket. That's how you comment out HTML. I do it because I like to keep that console, that little web developer's console clear of any errors I actually have control over. So that when I get errors that I need to see, like when I'm doing JavaScript work, because that's also where we're going to look for JavaScript errors. That's where we're going to have our debugging information output to. We're going to want to be able to read that. And so we want to keep it clear of as many errors as we can. Which is why I went through the effort of putting in a fave icon, because without the fave icon stuff, we were getting the error that there's no fave icon set. Oh no, what are we going to do? So, go to fave ico, feed it some 512 by 512 graphic that you've come up with, and it'll crap out a whole bunch of icons you can use for your page. You don't have to drop them all in the parent directory like I did here. Like, I could move all of these to image I would just have to go through the code here and uh, all of these href attributes. I would just do this. Clean that up a little bit. We're not actually using this one for anything. I just have it in the directory as an example. Now this manifest, uh, if you get it from the Fave Ico, it won't have a name or a short name. Those will be just empty strings. You'll want to put in your website's name, and you can also change your theme and background color, so that if you're going with some kind of branding, you can do that. This is how you are able to make apps for your phone that you don't have to distribute through like Google Play or the iPhone App Store. You can just make them as web pages. Set this stuff up, and then when you go to the page, do the option of add to home, and suddenly your web page is now as convenient as any app on any phone. And if you're really good with the JavaScript, um, you can make some pretty cool apps for your phone this way. A lot of people do it that way because then they don't have to deal with the whole hassle of distributing their product through, you know, Google Play or, the Apple App Store, which can be a pain in the butt to deal with. Besides that, they take like 30% of all of your sales. And like if you're selling anything through your app, if you have any in-app purchases, 30% of that's got to go to them as well. It's a lot. Honestly, it's just a lot. I'm gonna delete this zip file because that's just the zip file that I got from that faveicon.io. I just extracted it to the thing. But we'll leave the rest to that. So now it's looking a little cleaner. All right, let's see if we broke everything. Nope, our icon is still the same. If we go into more tools, developer tools, console's looking pretty clear except for this, which is something I'm outputting, and we'll get to that in a minute because that's something cool. You're gonna like this, especially if you're a holdover from the Python tutorial that we did. I'm gonna show you how we can actually get to using some of the information and the app that we made for our desktop with our website. What? Yes, that's right. We're going to be using our uh, our asset building Python program where we make those little comma separated value um, almost like Excel tables. And we're going to make that something we can use with our web page. Why? Because that little desktop app, as I said when we were making it, it's kind of a handy little thing for being able to crank out video game assets. Like, let's say you have a game where uh, you're some kind of knight going through a dungeon or something, and there's, random monster encounters every few steps. Your typical Zelda or any really RPG kind of setup, which you're all familiar with. You should be if you've played any kind of video games. And if you don't play video games, what are you doing with your life? What are you doing with your life? Play more video games. I don't care how old you are. Video games are for you. Anyway, uh how as a developer can we crank out the hit point values and names and like loot tables for all of these creatures that we're going to encounter in our game? Well, that little asset builder, that little cruddy buddy app that we made, will handle a lot of the work for us. It'll put it in the proper format, and then using just a handy bit of code, we can import that file into our web page. How do we do that, you might be wondering? Well, we use something called Ajax. Not the cleaner. Don't start, don't start huffing Ajax or something. That's bad for you. Ajax, AJAX, is a JavaScript technique. It's a little high end. I mean, it's one of those things that you find tutorials saving for like the very end. Heck with that. Okay? None of this. We're going to save the good stuff for the end. No reason for it. Okay? We've already talked about object-oriented programming here before. That's where you're grouping the variables that describe properties of something with the functions for changing those properties, all under a single variable name. Let me show you an example of that. Here we go. Now, I know this says function and not class, but this is a way we can declare an object in JavaScript. This is our sound object. It's an extension, essentially, of the audio object, which is already a thing that exists. But it adds a little more functionality to it. Because the standard audio object, it takes an audio file and then normally you attach it to like a document element, and then you would play it. It plays to the end before it becomes available to do anything with again. I mean, you can pause it or you can stop it. You can set the, you know, where in the track you are, that kind of stuff. But for our purposes, the purposes of making games, what we want to be able to do is say if we have a blaster noise, pew 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 pew. Well, we're gonna have one sound, little MP3 file that's pew, and we want to be able to play that in rapid succession without necessarily having to wait for that first one to finish, reset, and be available for the second one, because otherwise it'd be pew 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 pew. But we want pew 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 pew. So, how do we do that? Well, our sound object is actually going to be made up of several audio objects. Basically a repeat, and we'll be able to fire them in rapid succession. So, here's how we do that. We have our source, which is just an argument that we're going to feed into audio later, into an audio object to set up our actual audio property, which is just another object. We're going to set a number of streams so we can have multiple instances of our audio effect playing at the same time. And we're going to set up our volume. Now we're going to give the max streams and max volumes default values. That's what's going on here. You may remember this kind of behavior from when we did class declarations in Python, except this would be the init function, and there'd be a whole separate line that was class sound. Doing it in JavaScript, you can do it that way. There is a way to do that. In fact, there's several ways to do classes and objects in JavaScript. It's kind of annoying. Okay? So here again they're describing how, objects are really just collections of variables that act as properties describing the same thing. Like, you would have a name, model, weight, and color of a car. They're all describing a car. They're just different parts of how you describe the car. Methods are the various functions of that car, different things that it can do. This is a bad example though here because these methods would be doing things like changing its velocity, changing its direction if you had like a steer method. It'd be turning left or turning right. Accelerate would be adding to its velocity. Decelerate would be reducing its velocity. That kind of thing. Now, you can do it this way, where you just declare the car, and then in brackets, curly brackets, you set up each of the properties. And then to set up the here, I prefer this view better actually because it's a little easier on people. I know this code's a little hard to see, but whoop. Okay. We'll run that. Car type is whatever. Now we do and oh, right. Ah, it's not letting me do it. Anyway, what it should be doing is running this function. But apparently, it doesn't like that idea. I don't know why. I don't know why. Hey, Ube. Welcome to the chat. I am doing great. I hope you're doing well as well. Don't get caught lurking at work. Not really sure why that's not working. Wonder if it'll let me look at the console here. Maybe if I get rid of that line. Nope. It's just not going to let me do it. But I mean, I assure you this kind of thing would work. We're just probably not going to get away with it in W3 School's little testing sandbox. So, that's one way to do an object. Basically just cobble together the object in situ, essentially. However, sometimes you don't have all the values, but you know you're going to have sort of a blueprint. Like, okay, you know there's going to be a car. You might not know what kind of car, what model, how much it weighs, or the color. You do know it's going to have certain methods, though. And you may have more than one car, but you want to be able to tell them apart, which is why you give them distinct names. That kind of thing. Well, we've seen this way of doing it. See, here's where we've got that, where they show you how to do a function in that style. So like I said, it does work. That is the way to do it. For some reason, it wasn't letting me. Wasn't letting me. Let me see. Do they have anything on classes? Probably. Here we go. Classes. All right. This is the other way in which we can declare an object. You know how we can write a function and it's basically a group of code that we can rubber stamp wherever we want, and all we have to do is call that function later, but we define it first? That's what we're doing here. We're defining a class of the type car, and it'll have a constructor function that gets called whenever we create one of these, and that's where we pass in the arguments of like what kind of car, what year of car. We can expect our car to have whatever methods we gave it. In this example, they didn't add any of the fancy methods that they should have, like start, drive, turn left, turn right, brake, that kind of thing. They should have, but they didn't. Now, this is the part to understand. The class is not the object. It is the template for the object. So, you have the definition, the template set up, Here's how you actually create it. Okay? You give it a variable name like you would with any variable, whether it's a string, a number, or an object. But with an object, you use the new keyword, your class name, and then the arguments that you're passing to the constructor. The constructor function is like the init function of classes. Like what we saw in Python's class declarations, we always had an init function that gets called immediately when we created a new object, and that's where we would pass the arguments. You might notice there's no self that we're having to worry about here. That just is an implied thing. Don't know why Python hasn't figured out how to make it an implied, but that's the way it works. So, most of your class declarations are going to be made up of function declarations, but you're going to have the first one, the constructor, and that's where you set your properties most of the time. You know, your name, the year, whatever, and instead of using self, they use this, meaning this object, this one, this car, this car's name. When we declare a car, the argument that the name that we put inside the parentheses, assign that to this car's name property. The year that we're going to put in the parentheses, assign that to this car object's year variable. That's what they're saying here. That's what that is. All right. So now that we have kind of an understanding of what's going on there, let's take a look at my code here. We can fix this. So that it looks correct. All right. And the way we do that, we throw a class here. Constructor. Okay, just like what they're doing here. Now keep in mind the way that I had it set up, it does work that way. But that is kind of the older way that they do this sort of thing. JavaScript used to not have this class thing, okay? You would do the function style that I had here before, where you would declare a function, you would just throw a bunch of this same kind of thing in here, and it would work. Because JavaScript treats everything like an object already. And you can seriously just tack things on like you're, well, crazy. Just gluing stuff together. It's fine. It's okay with that format. It really doesn't argue with it. Now, you might notice there's this weird happiness going on here. What the heck is this? Well, I did this because the normal way of declaring methods inside of my JavaScript object with the way that I was setting it up before wasn't quite working. And the reason it wasn't working is because it's the other way of doing things. So I would have to declare a variable using this to attach it to the object that we're inside of. I would set it equal to an anonymous function, which is just a pair of parentheses, and then using this arrow thing. We refer to this in coding as an arrow function. You can do anonymous functions just wherever you want to drop them. You declare a variable equals parentheses, this equals and closing bracket into a curly bracket, and then you put your code in here. You could put your arguments here, but since it's not something we're calling later, usually with an anonymous function, you're not calling it later. You could, I guess, technically, because you are assigning it to a variable, but yeah, JavaScript has a few different goofy ways of doing things, is what I'm saying here. You don't need to master this, okay? But it is legit code. It would work. But we're not going to do that. We're going to do this, a much more sane approach. So what do we have here going on now? We have declared our class. It is sound. Our constructor will take our arguments, and it will set up these properties. And like I said, we have a maximum number of streams. The way we're using this, soundboard, there we go. We'll look at just this one here. This is probably the easiest one to understand. We declare a variable and assign that variable this object, the sound object. We have to give it a source, which for this one we're using from our assets folder, which is now full of sounds. We're using cat meow 14536.mp3. I got all of these off of Pixabay, by the way. If you're looking for free noise for your websites or your projects, Pixabay. It's where my intro and outro music come from. It's all free, royalty free. You don't have to credit, but you can credit the creators. For the little bit of use we're getting out of these, I'm not going to worry too much about crediting every individual creator because there's a lot of them, but I did get them all off of Pixabay. You can find these there. If you want the exact ones, I haven't changed up the file names really a whole lot, so just, go looking. Anyway, so we set the source, which is our file name. And remember, we're just passing that into the audio object when we create that later here. We're going to set the max number of streams, since we're not going to be happy with just one cat meow at a time. We're going to go with a maximum streams of 5. We can have 5 of these playing at a time. I'll show you what that effect sounds like. And then this is our volume. So we can adjust the volume of our sound effects. All right? Now, these are the arguments that get passed into this constructor function, even though we're calling the sound object. That's just how it works. Like I said, it's just like init. Max streams gets passed to max streams. Since we changed that 1 to a 5, this will be 5 streams total. Stream number is just kind of an index holder. We're going to default that to 0. We're going to set up the streams, the actual streams themselves, and for as many as we said we're going to have, we're going to loop through That's what this is. This is a for loop. We covered this a little bit in Python. Here it's got a tiny bit of a different setup. Okay? So we have the for keyword. In the parentheses, we have three parts. There's part 1, there's part 2, and there's part 3. These are really just 3 JavaScript statements. That's all they are, 3 JavaScript statements. You could put anything in there you want, but the general accepted way to do this is the first statement sets up your control variable for your for loop. Okay? The second statement is going to be what you evaluate to determine if you're going to have another loop. Okay? So here, what we did is we declared I for index. Set it to 0. As long as I is less than max streams, do this code in the curly brackets. As many times as need to be. And then, after each time we do that code in the curly brackets, this is just shorthand for increment I by 1. You could actually rewrite this with I equals I plus 1. Means the exact same thing, but shorter way of writing it is I plus plus. All right, don't get hung up on the semantics there. If you write it longhand because you're not good with the little shortcuts, that's fine. That's totally okay. All right. I mean, some people will probably go, "Why didn't you just use plus plus?" You don't have to explain yourself to them. As long as your code works, you don't have to explain yourself to them. All right, so what's going on inside of the loop? Well, remember we have this list, or as it's called in JavaScript, array. It's literally just the same thing. It's a list. We're going to push a new audio object onto that list. So we're going to tack on another one, And like I said, we set that to 5, so we're going to do this 5 times. And it's just going to be the same file 5 times as a list. And for each one of those, we're going to set the volume property of that audio object, because this is just a list of audio objects. We can manipulate those as objects. You can actually look up the There we go. All right, audio. It works a lot like our sound object that we created, in that you feed it a file name. Hopefully you're feeding it a legitimate, like, MP3 or some compatible, actual audio file. But it has a whole bunch of different methods and stuff that you play with, like play, pause, stop. There's a bunch of different properties and whatnot. This page does not give us a whole lot of information on it. Here we go. It's essentially the exact same thing as an HTML audio element, in that we have, controls. That'll be a true or false. src is your source. You can set the type to however you need it. When you're declaring an audio object in HTML, you do an open and close bracket, and then inside you can list several different formats. That's what the use case here is. Like, say we have an MP3 recording of it, but we know that the OGG file type is lossless audio or something, and like just slightly better, and we have one of those. But we're also aware not every browser works with the OGG file type. So sometimes we'll get good results with that. Other times it'll just break the whole thing. So what we're doing here is we're listing multiple sources. MP3 is sort of your catch-all. That's the kind that works on everything. It's compatible with all of them. But it may also not be the best file type. So if you have the same recording in a different file type, you want to list them in the order of like the best, but then end with your catch-all, like you're most likely to be compatible with everything, but maybe not the best recording of it. All right? Kind of like what we did with fonts, you know, where we have the font we wish we could use, followed by the font we'll use if that one's not available, followed by the font that we'll settle for if we just have no better option. A lot of programming, especially for web development, because you can never predict the browser people are going to use. You can never predict the device people are going to use. I mean, you kind of have to do, you know, multiple uh, multiple cases all at once. Okay? Um, it's just kind of the way you have to think when you're doing web development. When you're doing desktop development, that's not necessarily the case because you're developing for the environment. And the environment is usually the same. Every Windows computer is essentially the same. Even if the user has done stuff to the environment, you can still expect a Windows setup is going to be able to understand Windows media files without a problem. All right. And that's because that's just a default that that operating system comes with. That said, you're absolutely fine if you just want to go with the one that has the best compatibility. Usually that's MP3 or WAV. OGG, as you can see, it doesn't work with Safari. It's supposed to work with Chrome, but I did test out a couple of OGG files yesterday, and Chrome didn't want to play them. I don't know why. So I don't know. This table is not definitive, not 100% accurate, but MP3 generally works on everything. Just like with video, because video's another one of those. Yeah, you can put videos in your browser. And you're going to do a lot of the same sort of thing. You're going to define your video element. You're going to put a height and width in there, which should be the dimensions of the actual video file. And you're going to have an open and close. A lot of people put this, your browser does not support the video tag. And as you can see here again, they have a stack of source files. And it works the exact same way as it does with audio, where there's going to be boom, ba-doom, ba-doom. The one you hope will play, ending with the one that you'll settle for because it's got the most compatibility across all browsers. And MP4 is generally the one that works across everything, because again, here you can see OGG doesn't work with Safari, probably doesn't work with Chrome, but MP4 generally works across all browsers. So it's a good one to go with. MP3 for sound, MP4 for video. You'll put that as your last case or your only case source, if that's your plan. But you can have, using JavaScript, you can set up your controls. Get element, it just pulls in that video. And it uses that same object model. If it's like, oh, this is an HTML video, it's going to have its video object applied to it. So it'll have the same methods. So like a pause, a play, properties will be width, height. There'll probably be a position or a seeker, whatever, so you know how, at what point in the video you're at. That kind of thing. You can extend these by doing things like adding these functions to make them wider, make them smaller. You can adjust the volume by adding functions to make them, louder or quieter by just changing the volume property of that video object. So that's a thing that already exists, though, in JavaScript, the audio and video. And the reason it already exists is because it exists in the HTML. And those objects are essentially just part of the document object model that we work with. That document.getElement by ID, whatever. If it returns an audio object, JavaScript's got to have an object to handle that. So there will be properties for that audio object. We can play with those. So let's get back to the code we're playing with here. All right, in our own, we have a class of sound. I think I've messed with that enough. All right, now we have the stop, which is just going to call the audio object's pause on whatever stream is playing. And then it's going to set the time for that stream to the very beginning. When we hit play, it's going to call whatever stream is available. I also have this weird little check in here if the sound is on. I picked this trick up from some coding tutorials on making games. Setting sound as a constant means there's only one place you have to change the sound. All right. And we do this for debugging purposes. If you wanted to make it so that your user can turn the sound on and off, don't make that a constant. Just let, and then you can have a switch or a button to toggle the sound on and off. You could even set a default audio for sound effects and music and pass that in here. So your user could change, the across the board how loud they want their sound effects, and you would just feed that in to your sound object every time. And then if you set up background music as another object, you could do the same thing. Like that's how that works. So what are we doing here? We're looking for because we're just kind of cycling through with that stream number, which was, like I said, just an index for our which stream is the currently active stream. So every time we hit play, it's going to cycle to the next one, and then it's going to play that one. That way we don't have to interrupt that one to play it again. Right? It'll just play over it. And unless we only set it to one stream, in which case you'll only be able to play it when it's available. So anyway, let's make sure our changes worked here. Oh no, they didn't work. What happened? We broke something. Script 53 cannot read nan. Not a number. What's not a number at 53? It's doing it again. All right. This is a really stupid fix. I shouldn't have to do this, but what it's doing is it's probably deciding that my play is its own freaking object. It's not. It's a method of an already existing object, okay? I don't need this kind of aggravation in my life. There's a problem with the file. What's the problem? There we go. Reload. See, now it works again. This is why I had it set up that goofy way before. Because for some reason, and I do not understand this, I have been trying to figure out why it's doing this, and it was just about giving me fits yesterday. Which is why I had it doing things in the weird way that it was doing things when we started this stream. For some reason, even when I'm declaring a class and it's inside of a class and I'm declaring these as all functions of that class, it will decide this one is its own separate object. Which means when I'm declaring this inside of the play function, it means, oh, the stream num property of your play object, not the stream num property of my sound object, mind you, which we've declared here. We've been playing with this whole time. No, for some reason when we get down here, it decides it can't possibly be that one. It's got to be this other one. So it's a problem of scope. And the way I've been getting around this problem of scope is forcing it to be a function. I'm forcing this to recognize that it's a function by taking this play, declaring it within the scope of this constructor function, making the value of play an anonymous function, and using this arrow syntax to declare to actually declare the function. This prevents it from deciding of its own free will for whatever reason, because JavaScript can be weird sometimes. So to prevent it from declaring itself an object of its own free will, I have to roundabout force it to be a function. Now, I could throw the function keyword here, and and you would think that that would work. No, because you see, there was an old way of declaring objects where we would declare them as functions, because functions are treated as objects in JavaScript. And so we would still be running into that same problem, because it wouldn't know if we're trying to declare a function or an object. This is the only way that forces it to understand we mean function here, not object. Function. Okay, this is a method of this is a method of our sound object. All right, so now this should work. It works. Okay, so it's annoying, but sometimes you have to take the roundabout way to get to where you're going with JavaScript. That is why it is worth knowing different ways of doing things. All right, and the different ways you can declare functions, and the different ways you can declare objects. So I do suggest taking some time to look those things up. I'm not going to hammer home on all of that stuff because, like I said, I'm not looking to turn you into a Google, next head developer for, some big tech company. I'm just showing you how you can make ridiculous stuff on your own with very, very limited information, but resources to find whatever you need. Now, this whole creating a sound object, like I said, I got this idea from actually following a tutorial on game development that showed me how to make asteroids. So it wasn't so much a here's how to make games. It's just here's how to make asteroids. But I did find their method of making multiple use sound effects quite clever. So, I've gone and just run with that ever since. It works, though you do run into some weirdness occasionally. Like it still works the way it's supposed to, and oddly enough, I could pull up that file where I made the asteroids game, and I don't have to do this there. I do this the way you're supposed to do it in that file, and it works just fine. I literally just copy and pasted the code from that into here. This whole class definition, there's no difference, but for some reason, that's where it started giving me the problem of trying to make this play function, this play method, its own separate object, distinct from my sound class. I don't understand why it's doing that, and I did find this works though as a workaround. It may seem very strange, and it is, that that's a thing that you would ever have to do. But it solves the problem. It works now. Is it an ideal solution? Not really. But that's the thing with JavaScript sometimes. You don't always get an ideal solution. In fact, that's the way it is sometimes with any programming language. Sometimes you just aren't going to get an ideal solution. The important part is result. All right? It doesn't matter how you get there so long as you get there, and you can get there consistently. With this, it's a little ugly looking, if you ask me. But the end result is something that works. Now, what else am I doing here? Because I'm clearly doing something else with this soundboard. Because I'm listing all of the other sound files in my assets folder. Setting their default volume to 1, giving them all 5 max streams. I don't have to set these volumes. That's really just a lot of extra typing I did for no reason. But what am I doing here? Okay. First, let's look at what we did to make the click button. Because as you can see, when I want the cat to meow, I press the big green button in the middle. How am I pulling that off, first of all? All right. Well, first I set up a variable. That's what this is, just setting up a variable. I assign it a reference to my center class object. As you remember, when I did this whole thing with the... I didn't show you the HTML for this until just now, did I? But I set the class as center. This is the only object that's using this center class, thankfully. I mean, I probably should have come up with a better name here, because usually when you're doing a center class, that's to like center align text. And then you would apply it wherever you need to. So, not the best use of naming here, but it works for my purposes for this example. So I got that element by the class name. Now, getting elements by class name, because it's a class and can apply to multiple, we're going to get multiple results. So it's going to make this a list of those results. Okay? Even if there's only one, we're still going to get a list. It's just going to have only one thing on that list. All right, then we declared, like I said, our sound effect, the meow sound effect. Made that a sound object thanks to our blueprint here. Our funky, misshapen doesn't quite work the way it's supposed to, but it works the way that we need it to. Blueprint. And then on that button that we got, that green button, since we know it's a list, but we know it's a list that only has one element, we're going to target that first element in that list. And we are going to add an event listener. What's an event listener? I hear you already saying. Well, when you interact with a web page, the various things you can do are considered events. Clicking, scrolling, double-clicking, left-clicking, right-clicking. Even the page loading, that's an event. And, trying to see if I can get... Nah, it's not going to give me a... We'll just have to look that up. No, I don't want to use the microphone. See, this is why I never use this. I don't use Chrome. I'm just trying to look up events in JavaScript. See, I should have gone to W3. Would have made things so much easier. All right. On click, we can use that as an actual attribute for our elements in HTML. And we often do that with form buttons. It's a great way to actually do it's a great use of JavaScript. Like here, okay, notice they're using HTML to set up a button element. And they've set the on-click attribute to do this little bit of JavaScript here. And they've just got it right between the quotes, just a line of JavaScript. And this will run when we click that button. Notice that the line of JavaScript just targets the element ID demo, which is this paragraph here. And it changes the inner HTML to whatever's returned by the date object. Current date, Wednesday 30th of March 2022. The time now is 10:45 Central Daylight Time. We're not going to talk a whole lot about date. We might get to that eventually. But all you need to know is they're taking the inner HTML property of whatever element object is returned by getElementID demo. There should only be one if it's an ID. Remember, it's not going to return a list. It's going to return one. And it's going to be whichever element it has that ID attribute within this document. Okay? And it's going to do that on click. In the body, you can do an onload event. We're just going to use the exact same sort of thing they did here. Literally, same thing. Hit run. It's not going to do it because the onload only happens when the page loads. Do I have a good example for that? I probably don't. Because I don't think we're running anything currently. Oh no, I am. I am doing that. Let me show you how it's working on mine. See this? See this being outputted here on the side? This weird little tiny script. If you look closely, look very closely, you're probably going to recognize that if you watched my Python tutorial as the contents of my kitten file. Which was a file we made and remade a couple of different times using the app that we built for our desktop using Python. How did it find its way here? Well, I took that same file, that exact same file. I threw it in the assets folder where I throw everything, but it's right there. Kittens.txt. Just dropped it right in there. Like it's nothing. And then onload, that's the event that triggers this line of JavaScript. What is this line of JavaScript? This is a function call. Read doc. Source is assets/kittens.txt, which is the location of that kittens file. And that log underscore file output is just the name of another function. All right? Because the function we're calling requires, as arguments, a source file and a function. And this is another bit of cleverness that I can't take credit for. I stole this idea. But this is where Ajax comes in. Remember earlier I was saying Ajax was a thing, but I didn't really talk about it. I just kind of got on a tangent about a whole bunch of other stupid stuff. This is what that is. Okay. This is that function, read doc, that is being called by the body's onload event. When the body loads, it calls this function. What happens in this function? Well, first thing we're doing is we're setting up an HTTP request object. We're using that new keyword. We're not passing in any arguments here. This is just XML HTTP request. That's an object in JavaScript. It is provided just as a standard object that we can play with. This is already included in JavaScript. We don't declare this. This already exists. It has a few properties that we can play with. And in fact, let me get... did I not? I didn't, did I? Nope, I didn't. That's okay. I thought I had already had this bookmarked in my Firefox. One of the things I do in prep for these little sessions is I have Firefox, my default browser, with all the resources I'm going to be referring to during my session pinned, and then I just copy over the address into Chrome, and I use Chrome as my on-set browser, which is why I'm not using Firefox, because Firefox, that's my go-to for everything browser. You don't need to see my work history and all that stuff and the research I'm doing for my podcast and everything in there. Although some of that will bleed through because I also use Chrome as my on-screen browser for my podcast as well. Chrome is kind of my clean environment where we're not going to get a lot of clutter. Anyway, so what we got here is our Ajax introduction. What does Ajax do? Well, it can read data from a web server after the page has loaded. I know what you're thinking. That sounds like a whole lot of crap I don't understand. All right, so as you know, our website, all of this, the source code and everything, is stored on a web server. Sometimes when you've loaded a page, you want the user to be able to receive updated information or an updated view of information that's on that page as it changes. And it might change due to, I don't know, global events, stock market, information that the user gives you. We don't know. Like, there's all kinds of different uses for this. It can be used for everything. But anyway, we're using it in probably the most simple form humanly possible. By taking a text file we have written, a text file we may make changes to at some point, so we don't want to just assume that we know the information in this file. We're going to load it in from the file so that if this file changes, those changes will be reflected next time we load this page. Do we necessarily need Ajax for that? No, but Ajax provides a very simple way of doing that. It'll update the web page without reloading the page. Technically, this is just JavaScript. Does that. You can use JavaScript to write information to elements without having to reload the whole page. That whole document.getElementById, quote demo, unquote, close bracket, inner HTML equals something, and then suddenly that div or that paragraph has whatever that something is as its internal text. Very standard JavaScript thing. That's a thing you're going to see a lot of. However, the thing that you're going to see more of than what we've been showing is instead of it being just any old string of text, it will be a string of HTML so that you can format your text into tables or other forms of, grouping. Like you can put them in different divs and move them around and position them how you like so that you can present your data the way that you want to present your data using HTML and CSS to make it look pretty. So it's not just going to be a plain, bland old string. All right. However, you will have to set up what that string is instead. Now, it can also send data to a web server in the background. We're not going to talk about that until we get to back-end development, because there's no point in talking about that until you get to back-end development, which is why we're not talking about forms. Because again, until you can do something with that information, what's the point? Right? Why fill your tutorial with endless inputs for text and radio buttons and checkboxes if you can't use it? If it does nothing, I'm not going to do that to you. We might play with buttons later, but we're going to have those buttons actually change things on the page where we're playing, where we can see it, where it actually goes down. We're not going to have you fill out a form, but then because we're not talking about back-end development, just be like, well, that's how you make a form, because you've left out the important part of how to submit that data. If you don't talk about how to submit the data, you have basically just wasted everybody's time. Don't do that. Probably my biggest pet peeve with other people's JavaScript tutorials is they'll give a front-end development JavaScript tutorial and then they'll just talk endlessly about things you can't do anything with until you start learning back-end development, which is a totally different animal. Completely different thing that you'll need to worry about much later. For now, we're going to not worry about sending data to the web server in the background. We're not going to bother with it. Not important. So, let's take a look at one of their examples here. Do they have an example? They don't have an example. Why don't they have an example? Oh, here. Here we go. Okay. So as you can see, to load the document, they too set up an HTTP request object. Well, an XML HTTP request object. Same as we did. Now they have changed the onload of that object to a function that targets the demo, which is this div up here, to display the response that it gets. So let's see what that does. Oh, hey, look, isn't that cool? Now, what are they doing to get that response? Okay, so they open a GET request. There are two kinds of requests. There's GET and there's POST. You use POST if you're sending information to the server because it keeps it anonymous. It doesn't put a whole bunch of stuff in the URL. You use GET if you're retrieving information. I mean, you could technically use POST or GET for either or, but there is a difference in the way the data is transmitted. GET it does this thing where it tacks stuff into the URL, makes it very public, I guess. So I don't recommend that if you do get to that part where you're doing some back end development and you're sending information to the server. Like, you don't want to do that. Use post. Okay? Use post. It keeps all of that information that was put into the form out of the public view. I mean, it's not entirely private or encrypted or anything like that. You have to worry about like HTTPS for stuff like that, and data encryption, things like that. Things that will be talked about if we get to back-end web development. Okay, because that's where that'll be important. But because this request, much like the request we're doing on our page, is just fetching information out of a text file that is already in already a part of our our directory, we can use get and then the file that they want to fetch from the web server. So it'll open that request and then it'll send it off. Now, the first A in Ajax stands for asynchronous. Asynchronous. That means when we're doing this, it's not going to hold up everything else that's going on. Okay, this will just kind of get kicked to the background, and when we have a result to report on, that's when things will get updated. Asynchronous JavaScript and XML. Although XML is less important these days. More often you're going to see JSON or straight up HTML. But we're still using the XML HTTP request object to do it. And then we manipulate the HTML DOM object to display the information. And like I said, kind of misleading because we're no longer worried so much about XML because we can use JSON and other ways of transmitting data that are just a bit more efficient. So, XML is a lot like HTML, except that it's just a way of organizing the content of a file. There'll be tags like, denoting title and paragraph and various properties. But we're not going to get hung up on that because we're not going to worry about that. We're not transmitting things with XML. We're not worried about XML. The object we're using, though, is still going to be that XML request, XML HTTP request object. Okay? So how does it work? An event occurs. In our case, in our file, the body loads. Body on load. That event occurs. We run this function, which creates our XML HTTP request object. And then we send that request. I mean, first we want to change a few properties of it before we just kick it off. But, you know, namely we have to, uh tell it what file we're requesting, the method by which we're requesting it. We're just using get here instead of post. And then we send it off. Goes across the internet. Server gets that request, creates a response, and sends back the information. In the browser where that object was created, it'll then process that response using JavaScript and update the page content. Here is where we tell it what to do when we get the response. This is the process of the response. This object has an onReady state change. Okay? And onReady state change is the placeholder for a function call that'll get tripped every time this object has an update. But this object's going to go through a few phases, okay? And we want to know when the object is done. Okay, we've received the response, it's done. And in order to know that, we're going to check the ready state of the object and the status of the object. And if the ready state is 4 and the status is 200, we'll know that it is done. When it is done, we're going to kick off this function, which is the function that we fed here, log_file output. Okay? You can put anything here. You don't have to kick off another function. You could just have it target some element on your page and change the inner HTML if you want to. But because I foresee we're going to have multiple uses of this Ajax, because this is a very standard blueprint of how we handle Ajax. That's why I'm not giving it a file name here, but rather making that an argument that I feed it here. So I feed it this, I can feed it any file. And then it'll request any file that I ask it to. It'll just use this same function. But I may not want it to respond the same way every time, so I'm also going to feed it a different function as the response. This is the response of receiving a response back. This is where we're going to process that. How are we going to process that? Well, the function we're giving it is the log_file output. Log_file output just takes the response from our HTTP object, which, is just this because we're declaring the HTTP object, and then on its ready state change, declaring that function where it checks the status, calls whatever function we fed up here, and feeds itself to that function. Okay? I know that seems a bit weird, but when it feeds itself that function, we're feeding it an HTTP object, the XHTTP object. All right? So the function we're calling is ready for it. And we're going to call from that object that we fed it the response text, which is literally just the contents of the file we requested. But because it's going to, whoop, nope, that's not what I wanted to do. Put you back. Yeah, let me show you what we get if we take that last little bit there off of the end. As you can tell, it is just straight text. Okay? Just text. This is all just one big string. Now, maybe that's what you want to do, but for our particular case here, we want to manipulate this text to be something useful in our JavaScript. So what I'm doing is I am taking that text, I am splitting it up into a list, an array. Array and list are the same thing. Python, they call them lists. JavaScript, they call them array. Same thing. You even use them the same. They even have a lot of the same methods, as you've seen. Split is a function that you can call on any string. It is a string method. What you're going to do is feed it some characters at which you are going to split this string into the elements of your list. The formatting here, because our text file is on a Windows system, it's going to need to split at a return new line character. Every time we have a return new line. Now you remember in Python we only needed to worry about new line? Well, we're on front-end development, and for some reason JavaScript just inserts the return character in our Windows text. So this is an operating thing. We can't get around this. So there will be a return character and a new line. So it's one of those weird holdovers from like back in the days of typewriters. The return was the big cylinder being pushed all the way back, and the new line was feeding the page by one line, progressing the page. Whereas the return was sliding it back over so that you could start typing at the beginning of the line again. If you did the R with no new line, you'd basically just be typing over it. But that doesn't really work in computers. So I don't know why it's still there. I don't know why Windows still needs this, but apparently they do. So we're going to filter out for at every point in our string of text where it encounters a return and new line character. That's going to indicate, okay, that's an element. That's the end of an element. What comes next is the beginning of a new element. And it's going to split these up and compile them into a list. And that's what we get here. We have a list. Now, just like when we were messing with this stuff in Python, our first element in the list is our headers, name, color, fluffiness. We could further process this out by taking this element and splitting it And let's go like this. File output. There we go. Our first line in the file output. Helps if I spell things correctly. There we go. Hit the reload. I missed a thing. Where did I miss a thing, though? That's what I'm wondering. Oh. There we go. And see, now we have our headers as a list. The exact same way we got them in Python. Well, not exactly. This is JavaScript, remember. But what can we do with this now? Well, since it's part of a list, we can loop through it, and we can construct a table with this. So we could populate, say, that first paragraph of our page. I split this. Here's that for statement again. We want to start at 1, because remember, the first line in our file output is that headers. We want to start at 1, which should be the first actual record. And actually, we should go with records instead of for consistency. There we go. Now, what this should do is that first line, the headers, will be a list. Name, color, fluffiness. Then we have records, which is going to push each line. After I finish filling out this for loop, it's going to go through each line, and it's going to push each element onto this list as its own list, split up at those commas. So, records will still look a lot like file output does, except each line, instead of being a line of text, will be its own list. It'll still have the same data, just, without the commas, and we'll be able to index through each one of those. All right, and that's going to be important for the next step of this, because the next step of this is we're going to create a table. Now that we have something useful for our table, we're going to make one. Because you might be like, well, we've not made tables before. We haven't done tables. How come you skipped tables when we were talking about HTML? Because what's the point of talking about tables if you have nothing to show for it? I may have already done this wrong. Maybe. So let's just check our work here. Reload that. Boom. Yes. Push is not defined. What are you talking about? Push is not defined. Oh. That's right. It's a method. There we go. All right. So, headers, there are 3 entries. And there's our data as a list of lists. Ta-da! So, now that we have our data parsed through and properly separated into lists, let's make our table. First thing we need is a placeholder for the text. All right. Now, this is going to be just some HTML. We're going to declare a table. And actually, let's do this so that I have some space to work with here. I know it's going to look a little funky, and it's going to be like, I can't do that. We're going to ignore that for now. All right, so when we declare a table, we need an open and closing tag. That's going to define the bounds of our table. Now, you fill in tables by row in HTML. I mean, you can declare things like the width of columns and stuff like that, and you can do column spanning where it'll join cells that are uh, adjacent to each other, you know, in columns or rows if you want. We're not going to get that fancy. Feel free to look that stuff up. It's all available. Where is their tables thing? Well, it was here. It would appear I'm either blind as a bat or they don't talk about tables. Oh, here we go. Tables. Yeah, it's all here. Okay. But our first row for our table, we're going to want to get rid of this and this. We're going to copy those out of there. Okay. Because at the end, we're going to tack those back on. Because these are our closing tags here. This is how we close out our table. We need to finish up whatever row we're on, and we need to close out the table. We're going to put those at the end of our string. Now, between here and here, there's going to be some work, though. First thing we want to do is we want to cycle through our it's throwing errors at me because I've got all this space here. It doesn't need to be there. Okay, there we go. Okay. Between those opening and closing tags, though, we have a lot of work to do. Now, we're going with J this time. Less than length of our headers. Because it's going to cycle through each of those headers. Boom, boom, boom. Right? Remember, that's just the shorthand for increment when done. Table HTML equals. We want to keep the text that's already there, but we want to add to it. What are we going to add to it? The tag for a table header. And then the header that we're currently indexing on. And then let's close our header. This should be true. This should be perfectly legit. For some reason, one of our things isn't loading. Okay, there we go. As you can see, we've got our table, open and close, our table row, open and close, table header, undefined. What? 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 Come back to that in a minute. Why is it returning undefined? Oh, because I forgot. Headers. Plural. Okay. Name, color, and fluffiness. Perfect! That's what we want. All right, so we know that's working. Here's what we're going to do now. We're going to get real fancy with it. Instead of dumping all of this to the console here, because I named that paragraph, right? I named it kitty table. Document.get element. Helps if I can spell element by ID. Where did my T go? There we go. Dot inner HTML equals table HTML. Did I spell document right? Okay. Dun dun dun! We have our headers. Name, color, fluffiness. Don't worry about the spacing right now. We can handle all of that with CSS. For now, though, just be impressed that this is working. Okay. So, big deal. We can loop through the headers and we can get those tacked on. Show me something impressive, wizard JavaScript man. Oh, I'll show you something impressive. What if I told you? We're going to end the current row and start a new one. And then we're about to get real fancy with it. Records. Length. What? What? No. No. What? Are you? No, you've got to be kidding me. This is insanity. Insanity. We are putting a for loop in a for loop? What? Yes, we are. Actually, I'm going to take this line here. I'm going to cut that. I'm going to put it right there. And then now up here we use TH. That's for table header or heading. Use that on the top row. If you want to have your headings bold, it's basically the like the H1 and H2 of tables. You use TH for table heading. TD just means table data. What? That's right, we are double referencing. Now, what this does is for each row, we're going to go through each cell and tack them on. Then we're going to close out the cell. All right. Once it's added on all the cells, it's going to close the row, add another row, and it's going to do this each time. And then at the end, it's going to close the row, close the table. Let's see if it works. What? That's right. Our kitten file is now a table. This is, however, a bit disturbing because this is that last record. We have an extra line return there. Now, because we have that extra line return, we can do... Actually, let's do that up here where we actually add them. That should filter off that last file. Boom! Yeah! Like a pro. And now this table, we can do all the spacing and stuff we want using our CSS. CSS. Why is there a weird space there? That doesn't make any sense. You should all be on the line. Yeah, there we go. Okay. Now it's better. I don't know why there was that weird space there. Okay. So, TD. Well, we'll go TH and TD. Margin. Now remember the first value is top and bottom. We're going to go with a small margin. But then we want to do a slightly larger, so it really pops that there's some space there, okay? Boom! It didn't really do much. uh, yeah, no, that didn't do much at all. Maybe padding? No, that didn't do anything either. Well, okay. So I still have to figure out why the CSS is not working. Oh, you know what I bet it is? I bet it's that it's not actually even putting those on there. Yeah, see? Now it should work. There we go. A little bit of spacing. Makes the whole thing readable. We can get rid of that because we're no longer outputting things to that. Whoop. I'm never really sure which properties affect what for tables all that much. Okay, 4 is not great. I don't think margin is doing a darn thing. In fact, let me try commenting that out. Yeah, no, margin's not doing a darn thing. So, padding probably going to be your better option for spacing. There we go. Ta-da! Now we could probably also do something like setting a default height and width. I do tend to shy away from that kind of thing though, because like you'll start cutting off text if it gets to be too big for your data cell. Padding should expand the cell uh, around the text data. And the default is just to make the columns and rows as big as they need to be to hold the data. Adding a little bit of padding makes them a little bit bigger so that it's presenting nicely. Now we could do all kinds of cool stuff like with those other sort of selectors like there's some CSS selectors where we'd be able to, or even with our JavaScript, we could, you know, give them various classes to like highlight every other row if we wanted to. I'm not going to get into all of that right now, though. I just wanted to show you how, with a little bit of JavaScript, we can pull in and use data from an external file. And this is what we get when we do something like that. Totally useful. Totally works. Now, we are about out of time because I got to go get some lunch. But there is one more thing that I want to show you guys how to do today. We didn't get to canvas elements yet and sprite animation, but I was kind of not thinking we would anyway. I do want to show you, though, how it is every time I reload this page. we're getting random sound effects for these purple boxes. Even though it's still the same kitten effect every time for that one. Hello? Okay, so we go into our soundboard. And as you remember, I started a list. I have a list of the small buttons, which are just the purple cell elements. Got that by class name, targeting the class name cell, so it returned a list of elements. We have a list of sound effects, and I just pushed a new sound to that list over and over and over again with a new file name. Didn't really need the volume, but I put that on there anyway. Little extra typing. We did need the max streams though, because otherwise it would have only let us do it once, and in order to get that cacophony of noise, we need to be able to do it multiple times. So I went with 5 max streams. We could probably go as many as 10 or 15. If you have a game, you want to be generous with the number of streams to the point where you have as many as the user should be able to do within the amount of time that your sound effect runs for. Like if you have a laser blast noise and it's only about a half a second in length, your user's probably only going to be able to click the button about 5 times during the span of one of those playing. So 5 streams is fine. If your file's a little bit longer, say you have some, explosion sound effect or something that's, a long rolling explosion that takes a full second and a half. You want to make sure that the number of times that can be triggered before the first one ends, there's still more to go. So you can increase that number of streams there if you do it the way that I did it. So that's Anyway, what are we doing here? Pushing all the sound effects to a list. And then we cycle through that list of little purple buttons. And for each one of them, I'm going to pick a random sound effect. And how am I doing that? I'm using the math library. JavaScript, just like Python, has some built-in functions. One of those, specifically particularly useful, pre-built objects, is this math object that has a whole bunch of these methods that do things with numbers. Like the random, which will randomly spew out some number less than 1. Which is why I'm multiplying it by the length of our sound effects list, because it's going to pick a random number between 0 and the length of, or between 0 and 1, and then it's going to multiply that number by the length of our sound effects list. And then we're using the floor method to round that number down, because it's going to be some decimal, some random decimal. But to get it to be an integer, a whole number that we can use as an index for our sound effects list, we want to be able to round it down. We assign that to J. And then as we're cycling through our buttons, for each one, we're adding an event listener, same as we did up here with the center play button, which is just that center. we added the event listener for click and the function call. Here we're adding the event listener for click, and the function call is whatever J ended up being, the index on our list for the sound effects. So if J is, 5, 1, 2, 3, 4. Well, it's 0, 1, 2, 3, 4, 5. Would end up being a buzzer. We're going to play the buzzer sound, because the function call will be the play method of that sound effect. It does this every time we reload the page, so we always get random sound effects assigned to each of the 16 buttons. And that's also why we sometimes get the same sound effect for more than one of those buttons, because it just randomly selects one of the sound effects. It may select the same sound effect for all of them randomly. It may give us a flushing toilet for half of them randomly. Wow. That was totally not planned, by the way. That was not planned. Although, like I've got to give myself applause for the genius behind that. I wish I had planned that, but I can't. I can't say I planned that. That was totally by accident. But anyway, so what we got here is we got a little soundboard that all of these purple things have an on-click event. I mean, you can click anywhere else on the page. It's not going to happen. But if you click within the bounds of this purple cell, it'll play one of the random sound effects. And each one of them has 5 up to 5 streams. So you can click it up to 5 times and it'll trigger a new one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Plays the exact same length there, because once we hit that 6th one, if our first one isn't ready again yet, it's not going to do it. It caps it out at 5. That's just the nature of our sound object, if you remember. So that's how we got a random sound effect for each of those. I know we covered a lot. And I was prepared to cover quite a bit more, but I think this is a good place to stop, because I don't want to overwhelm your little minds with all of this. But let's just recap real quick. Ajax. You create an HTTP request object, an XML HTTP request object. On ready state change, you assign it a function. In that function, you check the ready state for 4 and the status for 200 to determine if the response is done. And when it's done, you can have your JavaScript do whatever you want. I prefer to just throw a function in here that I can define as an argument to the function that's calling this whole thing. Because then I can just reuse this over and over again. And I don't have to worry about retyping this for every stupid one that I want to do. And then get the file name. This true just means, do you want to run this this request asynchronously? The default is true. I don't need that true there. That's just some extra typing. I could turn the asynchronicity off. I don't know if that's a word, asynchronicity. But what that would do is it would cause all the JavaScript on my page to hang, waiting on that request to come back, waiting for some kind of response from the server. You don't want to do that to your user, so don't do that. Just leave it at true. Then we send that off. When it comes back, this function will trigger this function here. It'll check the ready state and the status. You can look up what this ready state and status for the XML HTTP request object means. This is the same as your HTTP error codes. Like when you see an error 404 because a web page didn't exist, if you're requesting a file, if we fed it a file that doesn't exist, it'll return a 404. And we could include a check here that instead of, running this function, would pop up an error. Oh, I'm sorry, the file you're looking for isn't available. But we're aware already on our end the file exists. We're sure of it. It's in that folder. So when this triggers, that file will be there because it's all on the same server. So if they're on this page, that file should also exist. We know this for a fact, but it comes in handy to know when you're doing things like the back-end development. You can change those codes. You can add more if statements to check other ready states and other statuses to determine if your request has been met with an error or not, or to update for each of the ready states. 4 is the last one where the response has been returned. Okay, and 200 just means status is good. Everything's a-okay. You didn't run into anything weird. But yeah, you can look up the various values. There is only a select few values that will be acceptable for ready state and status on an XML HTTP request object, and you could write if statements that handle all of the cases that you're likely to come into contact with and all of the various combinations of those. We don't need to worry about that for our purposes. We only want this code to run. If we get a ready state of 4 and a status 200, it'll kick off that function. If it gets anything else, it just won't do anything else, which is fine. Because what happens is that paragraph just stays the text that it was. And that's fine. We're not worried. Doesn't affect us all that much. All right, so that's Ajax for you. This is how you can pull in files that are just tables of data into your web page. When you get into back-end development, I'll show you how to generate on the fly that data so that when you make a request on a web page, the file doesn't have to exist when the request is made, but you'll still get this ready state 4 status 200 result. Because yeah, that's possible. All right. You can do stuff with the response, format it how you need it. You don't have to put it into a table, but we did. This is how you do tables with that information. These are all the tags that you're going to use if you're making tables. If you're not pulling information from an external file, you're still using table, table row, table header, end table row, start table row, table data. Oh wait, why am I ending that? No, that's supposed to be that. I wonder if that makes a difference. Not much of one. Not much of one. Okay. I didn't even notice that I had an error in there. But you end one row, you start another one, you end one data, you fill it in, or you start the data, you fill it in, and then you end it. End the table row, end the table. Same kind of nesting procedure you see like when we're doing lists. you know, when we're doing nested devs, or divs. Sorry, not devs. We're not nesting our developers. Um, you can declare objects in JavaScript, and this is kind of how you do that, except sometimes JavaScript is weird and throws strange things at you, and you're forced to do stuff like this, where you force things into being functions instead of objects within objects for reasons I don't understand. But anyway, objects are a thing in JavaScript because everything is actually an object in JavaScript, much like how everything's an object in Python. It's just, yeah. Uh, you can set up constant values and check for them. For debugging purposes, that's really good. Like I could have a constant of debugging equals, true. And then in things where I might wanna like, is that the value that I think I'm getting? Well, let's output it to the console. And then if I nest that inside of an if statement that just checks if my debugging is true, I don't have to go back and try to scrub my code for all of those little checks that I put in there. I just turn the debugging off and it no longer spits out a bunch of garbage to the console. But using get elements by class name, you get a list. Whether it's one or whether it's many, you're going to get a list. You can cycle through lists using for loops. It's fun. You do it much the same way you did in Python. Format's a little bit different, but like I hope that part makes sense. You declare a variable that you're using as kind of your index for your for loop. You compare that with some value to determine if you need to keep going, and then you increment it, and then you do some code in the curly brackets, and that code will be repeated. Hopefully, your index or something is being referenced in there. Otherwise, you're literally doing the exact same thing over and over again. But at least if you're referencing your index value, you can like progress through a list, stuff like that. Uh, I still didn't throw anything in our mains. There's probably a lot of stuff I should have in mains, and probably some of the stuff that's here in script probably doesn't belong in script, but that's okay. We have our files all connected. In fact, that soundboard, I tagged that here at the end, right underneath main. So, I'm pretty sure that's old. We don't need that anymore. But yeah, that's a little bit of what we can do with JavaScript in our page that has some uses. We can use it to manipulate the media that we're tying into our page, format the data that's into tables, make things appear or disappear as needed. Uh, I still haven't even covered the full gamut of what JavaScript's able to do. Because, like I said, we still have the canvas element to talk about. Haven't talked about the canvas element. Still haven't tackled the full list of event listeners either. I mean, we talked about click and we talked about when the document loads, but there's event listeners for key presses, key up or key down. There's event listeners for mouse over. So if you just hover your pointer over something, you can cause JavaScript to trigger that way. A lot of stuff we'll be able to do, and we'll get into more of that next time. This was a lot. I'm gonna go have some lunch. No, I really am. Whole lot of negative sound effects this time around. Thank you. Thank you. I hope you've all enjoyed this session of Murph Codes a bunch of stuff. Let's see. What do we got coming up this week? We still haven't recorded the next podcast session. I was too busy compiling and cobbling together today's JavaScript lesson. I hope you found it informative. So, next week, Tuesday, hopefully Zeph and I can sit down to record a little history on werewolves. Tomorrow, though, we've got Super Metroid on the Nintendo Switch online service, because I don't have a Super Nintendo, but we're still playing through the Metroid franchise. And let's see, I think the last thing we have to find is the screw attack. I don't remember if we found the plasma beam. I think we did. I think we found the plasma beam. I know we found the space jump. We still have to find the screw attack. And then I think there's still 2 bosses left before the end of the game. I think. I'm not sure. I've not beaten this one before, so I'm just kind of going off of what I can infer from experience with the other games and videos I've seen and what people have told me. Yeah. Oh, yeah. We also talked about fave icons this time around. So you can get little logos up there on the tabs and in the bookmark pages and stuff. As well as how to make your divs go underneath other divs in the case of scrolling and stickies. We talked about a lot this time, didn't we? So anyway, yeah. Next week we'll talk about the canvas element, being able to draw using JavaScript, image manipulation, sprites, hopefully. I'm gonna have to make some, though. I'm not great at making sprites. It's like, it is honestly one of the only things that keeps me from being just a beast when it comes to making games. Because I could make so many games if I had even the slightest bit of artistic skill. The only other thing I'm missing is musical talent. I have no musical talent. But, like, I can tell a story. I just can't draw the illustrations or compose the score. And, like, these are elements for proper game development to make really good games. You need good art, you need good music, you need a good story. I can do the story part. I mean, that's easy enough for me. And I can even interpret that story into code so that it does things and it works. And if I had the art and I had the music, I could turn those into assets for a game, as you've seen here. I have the talent. I just don't have the talents I wish I had. Anyway, so yeah, Mondays and Thursdays we're continuing our playthrough of the Metroid franchise. Tuesday, Zeph and I are still recording podcasts, not consistently, but we occasionally need time off. Okay, that's just fact of life. Wednesday, we're still doing this coding thing. We've still got a few more sessions here in the JavaScript, and then we'll get back to Python. And I'll show you how to do, like, network programming. And eventually we'll get into third-party libraries, which means also virtual environments and stuff like that. Fridays. Haven't told you what we're doing Fridays yet. We're still working on Breath of the Wild. We really don't have much left to do in that game, but I'm gonna try to get in at least 2 more sessions, hopefully, if we can. What I plan to do is at least 1 session where we're going to try messing with the physics of the game, since we've done everything. All the side quests, all the Korok seeds, all the shrines, all of the armor, all of everything. We have literally done everything. The only thing we haven't done to completely 100% this thing out is visited like a few obscure random locations on the map. And honestly, I'm not too worried about that. I mean, I'll probably just run out there sometime when I'm bored during the week and just, find where those locations are so that I get them out of the way. I'm not going to worry too much about doing that on stream because how boring, But yeah, we've done literally everything that there is to do otherwise in that. So, time to see what kind of trouble we can get into and break the game. Physics, we're going to try to exploit the hell out of that. We're going to try some of these item duping glitches that I've seen. Now that we no longer care about any of that stuff, because we have everything. Who cares if we make it so that we're holding 999 Hardy Duran? Nobody cares. What are we gonna do with that? Well, probably gonna fill Hylia Lake with Hardy Duran for no other reason than to have a little spiky ball pit. And then we'll start knocking Lizalfos into it for fun. I don't know what we're gonna do, but we're gonna have some fun. We're gonna have some fun with the game, just doing stupid stuff. And we're gonna do at least 1 session of that. Maybe 2, maybe 3, depending upon how lucky we get and how much fun we're having. We gotta have at least 1 session of Master Mode. So, there's gonna be, at minimum, 2 more weeks of Breath of the Wild. And then I plan on going to a random game every Friday. I'm gonna build myself a little randomizer that'll select the system and the game and whatever it tells me to play. That's what I'm gonna play. And I'm gonna feed this thing my whole collection of games, like everything I have. And I'm just gonna let it pick the game for me. Because I have a lot of games. So many that I haven't even played myself. I've just been acquiring them. And now that I have time to play them, Let's play them! So we're going to have some fun with that. We're no longer doing a public domain horror movie every Saturday. I'm going to make that a seasonal thing. Like, when we get back towards October, I'll pick out a selection of public domain horror movies to show a couple of weeks on a Saturday night. Maybe we'll do like 3 double features or something. Or we'll do 6 weeks of horror. I don't know. We'll do something gearing up through the Halloween season with that. Coding thing, we're going to keep plugging along here till you can make JavaScript games. Then we'll return back to Python, where I show you how to do more stuff with Python. Once we're done doing stuff in Python, we're going to come back to web development, but hopefully back-end development, so you can see what the other side of this whole thing looks like. How to generate on the fly these data tables and stuff, and be able to work with databases so that you can have information that updates when you need it, as you need it. Can take information from visitors to your website and store that information. Oh, that was something I forgot that I wanted to talk about. Web storage. It's a new feature for HTML5 where you can store some data, but it's stored like within the user's browser and isn't actually exchanged with the server. So, we'll do that next time when we're talking about the canvas element as well, because I find that's a handy one for, like, if users want to be able to save their game. You know, they might visit your page, but they're probably going to want to save their game within their browser window, you know? It would be great if they could do, like, cloud storage saving, where they could save their game on their desktop, pick it up on their cell phone. But we're not going to get that fancy till we get to back end. That's going to require server communication on a level we're not ready for. And also a storage solution on the server side. All back end stuff. We'll get to that someday. But we're going to visit Python again first, because we've still got some stuff that I was planning to do there that we did not get to. And this front-end development has just kind of been a diversion from that, you know, so that we don't get too bored with things. If you have any questions on any of this stuff, feel free to join the Discord. I'm always happy to field questions. You can find the link to my Discord in the About Me section on my Twitch channel page. I've shared that link a few other places as well. I don't know if I still have it in end credits here, but you'll find out. Yeah, time for me to go have some lunch. Time for you guys to go get on with your lives and do stuff. Enjoy the rest of your day. And we will see you next time for more fun, crazy shenanigans. Till then, have a good one.